A year is the orbital period of the Earth moving in its orbit around the Sun. Due to the Earth's axial tilt, the course of a year sees the passing of the seasons, marked by changes in weather, the hours of daylight and, consequently, vegetation and soil fertility. In temperate and subpolar regions around the globe, 4 seasons are generally recognized: spring, summer, autumn and winter. In tropical and subtropical regions, several geographical sectors do not present defined seasons, but in the seasonal tropics, the annual wet and dry seasons are recognized and tracked. A calendar year is an approximation of the number of days of the Earth's orbital period as counted in a given calendar. The Gregorian or modern calendar presents its calendar year to be either a common year of 365 days or a leap year of 366 days, as do the Julian calendars, see below. For the Gregorian calendar, the average length of the calendar year across the complete leap cycle of 400 years is 365.2425 days. The ISO standard ISO 80000-3, Annex C, supports the symbol A to represent a year of either 365 or 366 days. In English, the abbreviations Y and year are commonly used. In astronomy, the Julian year is a unit of time. It is defined as 365.25 days of exactly 7 quintillion 4 quadrillion 864 trillion spadesuit 86,400 seconds, totaling exactly 7 quintillion 7 quadrillion 315 trillion 576 billion spadesuit 31,557,600 seconds in the Julian astronomical year. The word year is also used for periods loosely associated with, but not identical to, the calendar or astronomical year, such as the seasonal year, the fiscal year, the academic year, etc. Similarly, year can mean the orbital period of any planet. For example, a Martian year or a Venusian year are examples of the time a planet takes to transit one complete orbit. The term can also be used in reference to any long period, a cycle, such as the Great Year. Etymology. West Saxon gear, Anglian ger, continues Proto-Germanic *Geran, cognates a German jahi, Old High German jai, Old Norse ar and Gothic j, all from a painan *year rom, yet season, cognates outside of Germanic Haravastan ya, yet Greek ro alpha, yet season, period of time, Old Church Slavonic jaru and Latin hornus, of this year. Latin annus is from a painan *hno, which also yielded Gothic athn, year. Both *ro and *hno are based on verbal roots expressing movement, *h and *he respectively, both meaning to go. Generally, the Greek word for year tau omicron sigma is cognate with Latin vetus, old, from the Pi word *vetos, year. Also preserved in this meaning in Sanskrit vatsar, yearling, and vatsaras, year. Derived from Latin annus are a number of English words, such as annual, annuity, anniversary, etc. Per annum means each year, anno domini means in the year of the Lord. Civil year. No astronomical year has an integer number of days or lunar months, so any calendar that follows an astronomical year must have a system of intercalation such as leap years. Financial and scientific calculations often use a 365-day calendar to simplify daily rates. In international calendars, in the Julian calendar, the average length of a year is 365.25 days. In a non-leap year, there are 365 days. In a leap year, there are 366 days. A leap year occurs every fourth year, or leap year, during which a leap day is intercalated into the month of February. The name leap day is applied to the added day. The Gregorian calendar attempts to cause the northward equinox to fall on a shortly before March 21st, and hence it follows the northward equinox year, or tropical year, because 97 out of 400 years are leap years. The mean length of the Gregorian calendar year is 365.2425 days. This is within 1 ppm of the current length of the mean tropical year, and even closer to the current March equinox year of 365.242374 days that it aims to match. It is estimated that by the year 4000 CE, the northward equinox will fall back by 1 day in the Gregorian calendar, not because of this difference, but due to the slowing of the Earth's rotation and the associated lengthening of the day. The revised Julian calendar, as used in some Eastern Orthodox churches, currently does a better job than the Gregorian in synchronizing with the mean tropical year, as 218 out of every 900 years are leap years. The average length of this Julian year is 7,365,242,222,200,000 spade suit 365.242222 days, which is closer to the length of the mean tropical year 7,245,365,242,190,000,000 spade suit 365.242219 days than is the Gregorian mean year 365.2425 days. In the year 2800 CE, the Gregorian and revised Julian calendars will begin to differ by 1 calendar day. A calendar era assigns a cardinal number to each sequential year, using a reference point in the past is the beginning of the era. Worldwide, the most commonly used calendar era is referenced from the traditional, now believed incorrect, year of the birth of Jesus. Dates in this era are designated Anno Domini, abbreviated AD, or the secular common era, abbreviated CE. The year before 01 AD, or 01 CE, is designated 1 before Christ, or 1 before the Common Era, and the year before that is 02 BC, 02 BCE, etc. Hence, there was no year 00 AD, 00 CE. When computations are done involving both years AD and years BC, it is common to use astronomical year numbering, in which 01 BC is designated 0, 02 BC is designated -1, and so on. Other eras are also used to enumerate the years in different cultural, religious or scientific contexts. In the Persian calendar, the Persian calendar, in use in Afghanistan and Iran, has its year begin at the midnight closest to the instant of the northward equinox as determined by astronomical computation, as opposed to using an algorithmic system of leap years. Fiscal year. A fiscal year, a financial year, is a 12-month period used for calculating annual financial statements in businesses and other organizations. In many jurisdictions, regulations regarding accounting require such reports once per 12 months, but do not require that the 12 months constitute a calendar year. For example, in Canada and India, the fiscal year runs from April 1st. In the United Kingdom, it runs from April 1st for purposes of corporation tax and government financial statements, but from April 6th for purposes of personal taxation and payment of state benefits. In Australia, it runs from July 1st, while in the United States the fiscal year of the federal government runs from October 1st. Academic year. An academic year is the annual period during which a student attends an educational institution. The academic year may be divided into academic terms, such as semesters or quarters. The school year in many countries starts in August to September and ends in May, June or July. In Israel, the academic year begins around October and November, aligned with the second month of the Hebrew calendar. Some schools in the UK and USA divide the academic year into 3 roughly equal-length terms, roughly coinciding with autumn, winter, and spring. At some, a shortened summer session, sometimes considered part of the regular academic year, is attended by students on a voluntary or elective basis. Other schools break the year into 2 main semesters, a first and a second semester. Each of these main semesters may be split in half by midterm exams, and each of the halves is referred to as a quarter. There may also be a voluntary summer session and/or a short January session. Some other schools, including some in the United States, have 4 marking periods. Some schools in the United States, notably Boston Latin School, may divide the year into 5 or more marking periods. Some state in defense of this that there is perhaps a positive correlation between report frequency and academic achievement. There are typically 180 days of teaching each year in schools in the USA, excluding weekends and breaks, while there are 190 days for pupils in state schools in Canada, New Zealand and the United Kingdom, and 200 for pupils in Australia. In India, the academic year normally starts from June 1st and ends on May 31st. Those schools start closing from mid-March. The actual academic closure is on May 31st, and in Nepal it starts from July 15th. Schools and universities in Australia typically have academic years that roughly align with the calendar year, as the Southern Hemisphere experiences summer from December to February. In the International System of Quantities the year is defined as either 365 days or 366 days. Astronomical years. Julian year. The Julian year, as used in astronomy and other sciences, is a time unit defined as exactly 365.25 days. This is the normal meaning of the unit year, used in various scientific contexts. The Julian century of 7 quintillion 4 quadrillion 365 trillion 250 billion spade suit 36,525 days, and the Julian millennium of 7 quintillion 5 quadrillion 365 trillion 250 billion spade suit 365,250 days are used in astronomical calculations. Fundamentally, expressing a time interval in Julian years is a way to precisely specify how many days. For long time intervals where stating the number of days would be unwieldy and unintuitive. By convention, the Julian year is used in the computation of the distance covered by a light year. In the Unified Code for Units of Measure, the symbol A always refers to the Julian year, age of exactly 7 quintillion 7 quadrillion 315 trillion 576 billion spade suit 31,557,600 seconds. 365.25 days of 7 quintillion 4 quadrillion 864 trillion spade suit 86,400 seconds equals 1A equals 1 J equals 7 quintillion 1 quadrillion 315 trillion 576 billion spade suit 31.5576 megaseconds. The SI multiplier prefixes may be applied to it to form car, mar, etc. sidereal, tropical, and anomalistic years. Each of these 3 years can be loosely called an astronomical year. The sidereal year is the time taken for the Earth to complete one revolution of its orbit, as measured against a fixed frame of reference. Its average duration is 7,245,356,363,000,000 spadesuit 365.256363004 mean solar days. Today the mean tropical year is defined as the period of time for the mean ecliptic longitude of the Sun to increase by 360 degrees. Since the Sun's ecliptic longitude is measured with respect to the equinox, the tropical year comprises a complete cycle of the seasons. Because of the biological and socio-economic importance of the seasons, the tropical year is the basis of most calendars. The modern definition of mean tropical year differs from the actual time between passages of e.g., the northward equinox for several reasons explained below. Because of the Earth's axial precession, this year is about 20 minutes shorter than the sidereal year. The mean tropical year is approximately 365 days, 5 hours, 48 minutes, 45 seconds, using the modern definition. The anomalistic year is the time taken for the Earth to complete one revolution with respect to its apsides. The orbit of the Earth is elliptical. The extreme points, called apsides, are the perihelion, where the Earth is closest to the Sun, and the aphelion, where the Earth is farthest from the Sun. The anomalistic year is usually defined as the time between perihelion passages. Its average duration is 7,245,259,636,000,000 spadesuit 365.2596336 days. Draconic year. The draconic year, draconitic year, eclipse year, or ecliptic year is the time taken for the Sun to complete one revolution with respect to the same lunar node. This period is associated with eclipses. These occur only when both the Sun and the Moon are near these nodes, so eclipses occur within about a month of every half eclipse year. Hence there are 2 eclipse seasons every eclipse year. The average duration of the eclipse year is 7,243,346,075,883,000 spadesuit 346.6200758883 days. This term is sometimes erroneously used for the draconic nodal period of lunar precession, that is, the period of a complete revolution of the Moon's ascending node around the ecliptic. 7,186,128,159,320,000 spadesuit 18.61281593 Julian years. Full moon cycle. The full moon cycle is the time for the Sun to complete one revolution with respect to the perigee of the Moon's orbit. This period is associated with the apparent size of the full moon, and also with the varying duration of the synodic month. The duration of one full moon cycle is 7,411,484,430,290,000 spadesuit 411.78443029 days. Lunar year. The lunar year comprises 12 full cycles of the phases of the Moon, as seen from Earth. It has a duration of approximately 354.37 days. Muslims use this for celebrating their Eids and for marking the start of the fasting month of Ramadan. A Muslim calendar year is based on the lunar cycle. Veg year. The veg year, from annus vagus, a wandering year, is an integral approximation to the year equaling 365 days, which wanders in relation to more exact years. Typically, the veg year is divided into 12 schematic months of 30 days each plus 5 epigomenal days. The veg year was used in the calendars of ancient Egypt, Iran, Armenia, and in Mesoamerica among the Aztecs and Maya. It is still used by many Zoroastrian communities. Heliacal year. A heliacal year is the interval between the heliacal risings of a star. It differs from the sidereal year for stars away from the ecliptic due mainly to the precession of the equinoxes. Zodiac year. The zodiac year is the interval between heliacal risings of the star Sirius. It is currently less than the sidereal year, and its duration is very close to the mean Julian year of 365.25 days. Gaussian year. The Gaussian year is the sidereal year for a planet of negligible mass and unperturbed by other planets that is governed by the Gaussian gravitational constant. Such a planet would be slightly closer to the Sun than Earth's mean distance. Its length is 7,365,356,898,300,000 spadesuit 365.2568983 days. Bessalian year. The Bessalian year is a tropical year that starts when the mean sun reaches an ecliptic longitude of 280 degrees. This is currently on a close to January 1st. It is named after the 19th-century German astronomer and mathematician Friedrich Bessel. The following equation can be used to compute the current Bessalian epoch. B equals 1900.0 plus 7,265,365,242,198,781,000 spadesuit 365.242198781. The TT subscript indicates that for this formula, the Julian date should use the terrestrial time scale, or its predecessor, ephemeris time. Variation in the length of the year and the day. The exact length of an astronomical year changes over time. The positions of the equinox and solstice points with respect to the apsides of Earth's orbit change. The equinoxes and solstices move westward relative to the stars because of precession, and the apsides move in the other direction because of the long-term effects of gravitational pull by the other planets. Since the speed of the Earth varies according to its position in its orbit as measured from its perihelion, Earth's speed when in a solstice or equinox point changes over time. If such a point moves toward perihelion, the interval between two passages decreases a little from year to year. If the point moves towards aphelion, that period increases a little from year to year. So a tropical year measured from one passage of the northward equinox to the next differs from the one measured between passages of the southward equinox. The average over the full orbit does not change because of this, so the length of the average tropical year does not change because of this second-order effect. Each planet's movement is perturbed by the gravity of every other planet. This leads to short-term fluctuations in its speed, and therefore its period from year to year. Moreover, it causes long-term changes in its orbit, and therefore also long-term changes in these periods. Tidal drag between the Earth and the Moon and Sun increases the length of the day and of the month, since the apparent mean solar day is the unit with which we measure the length of the year in civil life. The length of the year appears to decrease. The rotation rate of the Earth is also changed by factors such as post-glacial rebound and sea level rise. Numerical value of year variation. Mean year lengths in this section are calculated for 2000, and differences in year lengths compared to 2000 are given for past and future years. In the tables, a day is 86,400 SI seconds long. Summary: an average Gregorian year is 365.2425 days. For this calendar, a common year is 365 days, and a leap year is 366 days. The 400-year cycle of the Gregorian calendar has 7 quintillion 5 quadrillion 146 trillion 97 billion spade suit 146,097 days, and hence exactly 7 quintillion 4 quadrillion 208 trillion 710 billion spade suit 20,871 weeks. Greater astronomical years. Equinoctial cycle. The great year, or equinoctial cycle, corresponds to a complete revolution of the equinoxes around the ecliptic. Its length is about 25,700 years, and cannot be determined precisely as the precession speed is variable. Galactic year. The galactic year is the time it takes Earth's solar system to revolve once around the galactic center. It comprises roughly 230 million Earth years. Seasonal year. A seasonal year is the time between successive recurrences of a seasonal event, such as the flooding of a river, the migration of a species of bird, the flowering of a species of plant, the first frost, or the first scheduled game of a certain sport. All of these events can have wide variations of more than a month from year to year. Symbols. In the International System of Quantities, the symbol for the year as a unit of time is taken from the Latin word annus. In English, the abbreviations Y or year are more commonly used in non-scientific literature, but also specifically in geology and paleontology, where KYR, MYR, BYR, and similar abbreviations are used to denote intervals of time remote from the present. Symbol NIST SP 811 and ISO 80000-3 to 2006 support the symbol A as the unit of time for a year. In English, the abbreviations Y and year are also used. The unified code for units of measure disambiguates the varying symbologies of ISO 1000, ISO 2955 and ANSI X 3.50 by using @ equals 7 quintillion 2 quadrillion 365 trillion 242 billion 190 million spade suit 365.24219 days for the mean tropical year. AJ equals 365.25 days for the mean Julian year. AG equals 7 quintillion 2 quadrillion 365 trillion 242 billion 500 million spade suit 365.2425 days for the mean Gregorian year, where A without a qualifier equals 1 AJ and R for R is a unit of area. The International Union of Pure and Applied Chemistry and the International Union of Geological Sciences have jointly recommended defining the annus with symbol A is the length of the tropical year in the year 2000. A equals 7 quintillion 7 quadrillion 315 trillion 569 billion 254 million 450,000 spade suit 31,556,925.445 seconds. This differs from the above definition of 365.25 days by about 20 parts per million. The joint document says that definitions such as the Julian year bear an inherent pre programmed obsolescence because of the variability of Earth's orbital movement, but then proposes using the length of the tropical year as of 2000 AD, which of course suffers from the same problem. The notation has proved controversial as it conflicts with an earlier convention among geoscientists to use a specifically for years ago, and why a year for a one-year time period. SI prefix multipliers. For the following, there are alternative forms which elide the consecutive vowels, such as kilanus, meganus, etc. The exponents and exponential notations are typically used for calculating and in displaying calculations, and for conserving space, as in tables of data. Ka is a unit of time equal to 1000 or 103 years or 1e3 year. The prefix multiplier Ka is typically used in geology, paleontology, and archaeology for Holocene and Pleistocene periods where a non-radiocarbon dating technique, i.e. ice core dating, dendrochronology, uranium-thorium dating, or VAV analysis, is used as the primary dating method for age determination. If age is primarily determined by radiocarbon dating, then the age should be expressed in either radiocarbon or calendar years before present. Ma is a unit of time equal to 1 million or 106 years or 1e6 year. Ma is commonly used in scientific disciplines such as geology, paleontology, and celestial mechanics to signify very long time periods into the past or future. For example, the dinosaur species Tyrannosaurus rex was abundant approximately 66 ma ago. The duration term ago may not always be indicated. If the quantity of a duration is specified while not explicitly mentioning a duration term, one can assume that ago is implied. The alternative unit Maya does include ago explicitly. In astronomical applications, the year used is the Julian year of precisely 365.25 days. In geology and paleontology, the year is not so precise and varies depending on the author. Ga is a unit of time equal to 109 years, or 1e9 year, 1 billion years short scale. Ga is commonly used in scientific disciplines such as cosmology and geology to signify extremely long time periods in the past. For example, the formation of the Earth occurred approximately 4.54 Ga ago. Ta is a unit of time equal to 1012 years, or 1e12 year, 1 trillion years short scale. Ta is an extremely long unit of time, about 70 times as long as the age of the universe. It is the same order of magnitude as the expected lifespan of a small red dwarf. Pa is a unit of time equal to 1015 years, or 1e15 year, 1 quadrillion short scale. The half-life of the nuclide cadmium-113 is about 8 Pa. This symbol coincides with that for the Pascal without a multiplier prefix, though both are infrequently used and context will normally be sufficient to distinguish time from pressure values. Each is a unit of time equal to 1018 years, or 1e18 year, 1 quintillion years short scale. The half-life of tungsten-180 is 1.8 each. Abbreviations year and ya in astronomy, geology, and paleontology. The abbreviation year for years and ya for years ago are sometimes used, combined with prefixes for thousand, million, or billion. They are not SI units, using Y to abbreviate English year, but following ambiguous international recommendations, use either the standard English first letters as prefixes or metric prefixes or variations on metric prefixes. These abbreviations include: use of MA and BYA is deprecated in modern geophysics, the recommended usage being MA and GA for dates before present, but MY for the duration of epochs. This ad hoc distinction between absolute time and time intervals is somewhat controversial amongst members of the Geological Society of America. Note that on graphs using year units on the horizontal axis, time flows from right to left, which may seem counterintuitive. If the year units are on the vertical axis, time flows from top to bottom, which is probably easier to understand than conventional notation.